Okay, for this circuit we want to determine a couple of things. The equivalent resistance seen across these terminals, and then a couple of the currents in the circuit, I1 and I2. Probably the easiest approach first is to see if we can reduce the circuit. If I look at this 4 ohm and 2 ohm set of resistors, any current going through this resistor is going to come down and also go through this. They're in series, so I can add the resistances together to get an equivalent resistance, 6 ohms. Now, at least when you're starting out with this, I recommend redrawing the circuit at every stage. So I'm still going to have my 6-volt source. I have this 3 ohm resistance, the 6 ohm resistance, and then this equivalent 6 ohm resistance. Now at this point, all of these elements are in parallel. They all share the same 2 nodes. If I do KVL around any loop in here, I'll find that they all have the same voltage drop. So this whole section here, Req, is going to be 1 over 3 ohms plus 1 over 6 ohms plus 1 over 6 ohms, which is 6 over 4 ohms, or 3/2 of an ohm. Now I could also combine these two at a time. I could take these two, say that equivalent resistance is 6 times 6, the product of the two, over 6 plus 6, which is going to be 3 ohms. And then the combination of this 3 ohm resistor and this 3 ohm resistor is going to be 3 times 3 over 3 plus 3, which is 9 over 6, which is also 3 over 2 ohms. Either way, I get the same answer. So Req is 3 over 2 ohms. Now I need the total current out of the source, I1, and the current through the 3 ohm resistor, I2. Well, now that I've got the equivalent resistance, I can just draw the equivalent circuit. My 6-volt source. This is 3 over 2 ohms. So this would be I1. So I1 is the voltage, 6 volts, over the resistance, 3 over 2 ohms, which is 12 over 3, which is 4 amps. Now I need to find I2. If I take a look at this first reduced circuit up here, I2 is the current through this 3 ohm resistor. I can use a current divider if I want to. If this is I1 is 4 amps, I2, so from a current divider, I2 is going to be I1 times 1 over 3 ohms, that conductance, over 1 over 3 ohms plus 1 over 6 ohms plus 1 over 6 ohms, which is 4 times a half, which is 2 amps. However, that's probably more work than we actually have to do. For my original circuit, if I do KVL around this rightmost loop, I see that the voltage across the 3 ohm resistor is 6 volts. So by inspection in Ohm's law, I2 is going to be 6 volts over 3 ohms, or 2 amps. Both approaches are correct. They give me the same answer. This one's just considerably easier.